previous lectures, we were discussing about the limit of a function, limit of an algebraic function. Now there are some more limits which I would like to discuss today. For example, I have limit infinity. Say I have x approaches to infinity. And x is not infinity, it is going towards the infinity. And what will happen to 1 by x? 1 by x will approach to 0. Or 1 by x square will also approach to 0. And 1 by x cube will also approach to 0. So whenever we have x will tend to infinity, that means 1 by x, in 1 by infinity will become 0. 1 by infinity कैसे 0 बनता है? देखिए, अगर हम 1 by 2 लेंगे, 1 by 3 लेंगे, 1 by 10 लेंगे, 1 by 100 लेंगे, देखिए जितना हम डिनोमिनेटर को बढ़ाएंगे उतना नंबर छोटा होता जाएगा. यानी अगर मैं डिनोमिनेटर को 20,000 लिखूंगा, नंबर तो 1 by 100 जो है वो बड़ा है 1 by 20,000 से. जितना मैं और बढ़ाऊंगा डिनोमिनेटर, अगर मैं इनफाइनाइट चला जाऊंगा, it will tend to 0. So that is why whenever you have x tends to infinity, then you must write 1 by x will go to 0, 1 by x square will also go to 0, 1 by x cube will also go to 0. Now for example, I will take an example like this. Limit x tends to infinity. Say you have 3x plus 4 upon 5x plus 6. Say my question is like this. Limit x tends to infinity, 3x plus 4 upon 5x plus 6. Suppose I will take x is infinity. 3 into infinity, that will become infinity. So infinity plus 4, if you add 4 to infinity, it will be again infinity. 5 into infinity is infinity. Infinity को आप 6 add करना चाहते हैं, so again infinity. So it is infinity by infinity form. So when you have any question of the type infinity by infinity, again this is indeterminate form. Again this is indeterminate form. So what we will do now? How will we simplify this limit? You see the degree in the numerator as well as in the denominator. So degree of the numerator is 1 and denominator is also 1. So highest degree is 1. So we will divide numerator and denominator by x. We will divide numerator and denominator by the term which involves the degree 1, because 1 is the highest degree. So what I will get? Limit x tends to infinity. This is 3x plus 4 upon x. Then whole divided by 5x plus 6 upon x. That will be further equal to limit x tends to infinity. 3x divided by x is 3. Then 4 divided by x. Then in the denominator 5x by x is 5. And 6 divided by x. So this will be the question will reduce to here. Now as x tends to infinity. Now as x tends to infinity, 1 by x will tend to 0. As x tends to infinity, 1 by x will tend to 0. So 1 by x अगर 0 है, तो this 4 by x will become 0. 6 by x will also become 0. So you will get 3 plus 0 upon 5 plus 0. That is simply 3 divided by 5. So the limit of this function, when x tends to infinity, limit of this function will be equal to 3 divided by 5. So this is how to solve such type of questions. I'll take one more example, slightly different example. So I'll take example like this here. Example. Limit x tends to infinity, twice x square plus 3x plus 1 upon x square plus 5x square plus 2x plus 3. Suppose I have a question like this. Limit x tends to infinity, twice x square plus 3x plus 1 upon 5x square plus 2x plus 3. So now check. What's the degree in the numerator? It is 2, highest degree. And denominator is also 2. So you divide x square, numerator and denominator. You will get limit x tends to infinity. It will be 2x square plus 3x plus 1, you have to divide it by x square. So x square इसमें भी divide हो जाएगा, इसमें भी divide हो जाएगा और यहाँ भी divide हो जाएगा, and divided by 5x square, यहाँ पर भी x square divide हो जाएगा, 2x divided by x, then 3 divided by x. Now limit x tends to infinity, slightly you have to simplify it. X square and x square will get cancelled. So you will get 2, then you will get 3 into 1 by x, then you will get 1 by x square, then divided by, you will get 5, then 2 into 1 by x, then 3 divided by x. See, so this will reduce to this question. Now you know, as x tends to infinity, 1 by x will tend to 0. So wherever there is 1 by x or 1 by x square, they all will tend to 0. So 1 by x and 1 by x square will tend to 0. So as x tends to infinity, 1 by x will tend to 0 and 1 by x square will also tend to 0. So this will go to 0, this will also go to 0, this will also go to 0, this will also go to 0. Your answer is 2 divided by 5. So that means the limit of this function, when x tends to infinity, limit of this function will be equal to 2 divided by 5. And limit of this function is 3 divided by 5. Now you must remember as a shortcut, when the degree of numerator and denominator is same, then the answer is coefficient of the highest term divided by the coefficient of the highest term here. Here high term is x raised to power 1. So its coefficient is 3. Its coefficient is 5. So 3 by 5 is the answer. Same is the case with here. When the degree is 2, denominator में भी degree 2 है, denominator और numerator की degree same है, then the coefficient of the highest term, उनका divide जो होगा, that will be the answer. That is 2 divided by 5. See, x square का coefficient 2 है, यहाँ पर भी x square का coefficient 5 है, so answer will be 2 divided by 5. Now, the question is, if you have degree different, suppose ऊपर ज़्यादा है, नीचे कम है, या ऊपर ही कम है, नीचे ज़्यादा है, उस वक्त आप क्या करेंगे? I will come to the next example. Now I will take another example. Say I have limit x tends to infinity, 3x square plus 4x plus 5 divided by 5x plus 6. Now see, the question is slightly different than the earlier example. Now the degree of the numerator is 2, whereas the degree of the denominator is 1 only. Yani degree of the numerator is greater than denominator. Now the degree of the numerator is greater than the denominator. Now what is the highest degree? Highest degree is again x square. So we'll again divide x square, numerator and denominator. What will we get? Limit x tends to infinity, 3x square plus 4x plus 5 whole divided by x square. That x square will be divided to this, that x square will be divided to this, and that x square will be divided to this, and divided by 5x plus 6. Here also x square is divided to this and x square is divided to this. This means I am dividing x square, numerator and denominator. What is x square? X square is the highest degree among numerator and the denominator. So limit x tends to infinity, it will be equal to only 3, it will be 4 into 1 by x, then it will be 5 into 1 by x square, then it will be 5 into 1 by x, then it will be 6 into 1 by x square. Now have a look. Now as x tends to infinity, 1 by x and 1 by x square both will tend to 0. Now what will happen to the question? Question will be, this will be only 3. This will become 0 because 1 by x is here. Here 1 by x square, because 1 by x square and 1 by x both tends to 0. So this is 0 plus 0. And here you have 0 plus 0. That means 3 divided by 0. That means the limit is infinite. So it is infinite limit. So it will go to infinity. That means if x tends to infinity, then this expression, this function, the limit of this function will also become infinite. Now this is when degree of the numerator is more than the degree of denominator. Then always the answer is infinity. Once the degree of numerator is greater than the degree of denominator, then answer is always equal to infinity. You have to remember this thing. Now if degree of the numerator is less than the degree of denominator, for example, I'll write here limit x tends to infinity, 2x plus 5 divided by 3x square plus 6x plus 1. Suppose you have this example. What you will do, you will again divide x square numerator and denominator, because x square is the highest degree among numerator and denominator. So you have to again divide by the same thing. So limit x tends to infinity. It is 2 into 1 by x, 5 into 1 by x square, then 3 plus 6 into 1 by x plus 1 by x square. Now as x tends to infinity, 1 by x will go to 0 and 1 by x square will also go to 0. So this is 0 plus 0 upon 3 plus 0 plus 0. That is 0 upon 3. The answer is 0. So we have now three things here. 3 cases के questions है यहाँ पर. एक है अगर ऊपर ज्यादा डिग्री है और नीचे कम है, then answer is always infinity. अगर ऊपर कम है और नीचे ज्यादा है, then answer is always 0. अगर ऊपर और नीचे बिल्कुल सेम है, तब आंसर है ऊपर वाले का हायर डिग्री का कोएफिशिएंट और नीचे वाले के हायर डिग्री का कोएफिशिएंट का डिवाइड, वही आपका आंसर होगा. So first example, second example, and this is the example number 3. So you take all the 3 examples. तो ये है how to solve the questions of the type once we have limit x tends to infinity. Now we will take another thing. Now next we are going to discuss exponential limits. Exponential limits किस तरह से हम solve करते हैं? What are the exponential limits? But before we go to the exponential limit, I'll take a limit n tends to infinity 1 plus 1 by n raised power n. I will evaluate this limit. This is very important limit, standard limit. Limit n tends to infinity 1 plus 1 by n raised power n. What is the value of this limit? So what you do, you consider only 1 plus 1 by n raised power n. Now without limits, first you consider only the function 1 plus 1 by n raised power n. This is the first term, this is 1 by n, and this is the reciprocal power of 1 by n. का reciprocal जो है, that is n. So I'll apply binomial theorem to this because it is 1 plus 1 by n raised power n. So it is equal to 1 plus n into 1 by n, then plus n into n minus 1 divided by 2 factorial into 1 by n का whole square, then n into n minus 1 into n minus 2 divided by 3 factorial into 1 by n whole cube, and then it will go up to infinity. It will be so on because it is the binomial theorem for any index. So that is 1 plus 1 by n raised power n. It is equal to 1 plus 1 because n and n will get cancelled, and you will get n into n minus 1 divided by 2 factorial into 1 by n square, then n into n minus 1 into n minus 2 divided by 3 factorial into 1 by n cube, then so on. This is the second step. Now it is further equal to 1 plus 1 plus 1 by 2 factorial. Now have a look here. This is n into n minus 1 divided by n square. See, it is n into n minus 1 divided by n square. I'll keep 1 n here and 1 n here. This n and n will get cancelled. It will be n minus 1 by n. Once n and n divide हो जाएगा तो ये 1 minus 1 by n बन जाएगा. So ये जो सारा है n into n minus 1 by n square, it will be 1 minus 1 by n. So I will write here 1 minus 1 by n. I will close the bracket. Then again, this is 1 by 3 factorial. Now see, this is, second thing is here, this is n into n minus 1 into n minus 2 whole divided by n cube. See, this is n cube. So I'll write n, then n, then n. This n will get cancelled. N minus 1 by n. Then it is n minus 2 by n, because n into n is again n square. This is 1 minus 1 by n into 1 minus 2 by n. It will be like this. So the second term will be 1 minus 1 by n, 1 minus 2 by n. How I have proceeded it like this, how I have simplified this, so it will be 1 minus 1 by n, 1 minus 2 by n. So you can note this thing here, you can note this thing, then I will come to the next thing. I will write here, it is 1 minus 1 by n into 1 minus 2 by n, then plus so on. Right? Now see, this is 1 plus 1 by n raised to power n. Now as n will tend to infinity, see, n tends to infinity, then what will happen to 1 by n? 1 by n will tend to 0. As previously we have, in the previous lecture, we have seen n tends to infinity, 1 by n will tend to equal to 0. So it will be limit n tends to infinity, 1 minus 1 by 1 plus n raised to power n, this is equal to. Now, जहाँ पर भी 1 by n है, वहाँ हमें value 0 देना है, so it will be 1. This will also be 1. This will be 1 by 2 factorial. Because 1 minus 0 will be 1. This will be 1 by 3 factorial. 1 minus 0 will be 1. 1 minus 0 will also be 1. Because it is 1 minus 0, it is 1 minus 0, it is 1 into 1. That is equal to 1. So it is 1 by 3 factorial only. So once this is 1 by 3 factorial, so I will write 1 by 3 factorial and then it is so on. Now, I would like to find the value of 1 plus 1, 1 by 2 factorial, 1 by 3 factorial. What I will do, I will recall one thing. This is e raised to power x. It is always 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. This is the expansion of e raised to power x. Actually, this is done with the help of Maclaurin's theorem, that how to expand e raised to power x. Now, in this class, you just remember this. E raised to power x is 1 plus x square by 2 factorial, x cube by 3 factorial, and so on. Once you put x is equal to 1, you will get e raised to power 1, that will be e. And here you will get 1 plus 1 by 2 factorial plus 1 by 3 factorial plus so on. See, once you put n is equal to 1, it will be 1 plus 1, 1 by 2 factorial, 1 by 3 factorial, and so on. So now you check here, it is 1 plus 1 plus 1 by 2 factorial, 1 by 3 factorial plus so on. So this and this is actually same, so it is equal to e. So I can write limit n tends to infinity, 1 plus 1 by n raised to power n is equal to e. So this limit is equal to e. So that means this limit is equal to e. So I can write here, prove that this limit is equal to e. This is how to prove this is equal to e in a simple way. Limit n tends to infinity, 1 plus 1 by n raised to power n. I have to prove this is equal to e. What I will do, I will consider only the function 1 plus 1 by n raised to power n, and I will apply the binomial theorem to it. How to apply the binomial theorem? Of any index 1 plus n into 1 by n into n minus 1 by 2 factorial, 1 by n whole square, n into n minus 1, n minus 2 by 3 factorial, 1 by n cube, and so on. It goes up to infinity. Now 1 plus 1 by n raised to power n is 1 plus 1. This is 1 because n and n will get cancelled, so it will be another 1. It will be n into n minus 1 by 2 factorial into 1 by n square, n into n minus 1, n minus 2 by 3 factorial into 1 by n cube, and then it goes up to infinity. Again, 1 plus 1 by n raised to power n, it is 1 plus 1 by 2 factorial into 1 minus 1 by n, because n और n square, जब आप एक n इस एक के साथ कैंसिल करेंगे, वहां एक ही n बचेगा, वो वाला n आप इस टर्म को डिवाइड करेंगे, वो n by n 1 बनेगा और 1 by n बन जाएगा यहाँ पर. सिमिलरली 1 by 3 फैक्टोरियल, यहाँ पर भी एक n इसके साथ कैंसिल हो जाएगा, वहाँ n स्क्वायर रहेगा, वो n एक इसके साथ डिवाइड, एक इसके साथ डिवाइड, वो ऐसे हो जाएगा, and then so on. Now as n tends to infinity, 1 by n will tend to 0. So it will be limit n tends to infinity, 1 plus 1 by n raised to power n is equal to 1 plus 1 by 2 factorial, 1 minus 0 becomes 1, 1 by 3 factorial, 1 minus 0 is again 1, 1 minus 0 is again 1, 1 into 1 becomes only 1, so it is 1 by 3 factorial, and so on. So this limit is equal to this series. This is series. Now ये किस टाइप की सीरीज है वो हम थोड़ा सा देखना चाहते हैं. उसके लिए मैंने कहा, we know e raised to power x is 1 plus x square by 2 factorial, x cube by 3 factorial. This is the expansion of e raised to power x by the Maclaurin's theorem. If you put x is equal to 1, you will get e raised to power 1, that is e 1 plus x की जगह 1, यहाँ पर x की जगह 1, यहाँ पर भी x की जगह 1, तो ये 1 plus 1, 1 by 2 factorial, 1 by 3 factorial. इस सीरीज को हम कहते हैं एक्सपोनेंशियल सीरीज. इस एक्सपोनेंशियल सीरीज का जो सम है वो e के बराबर है. सो ये भी तो एक्सपोनेंशियल सीरीज है, तो इसका सम e होगा. Therefore this limit is equal to e, and this limit is the basic limit, again the standard limit, exponential limit. So with the help of this limit, I can prove another limit also. So that will be the next thing. We'll discuss one more limit. Say, just we have discussed it, x tends to infinity. It was actually n tends to infinity. N tends to infinity. 1 plus 1 by n raised power n. Just we have proved it is equal to e. Now it will we'll modify this limit. What we'll do, let 1 by n be equal to x. Just you put this 1 by n is equal to x. That means n is equal to 1 by x. That is, n is equal to 1 by x. Okay, because n is reciprocal, it will be 1 by x. Now as n tends to infinity, 1 by infinity will become 0, that means x will go to 0. See, जब आप n की जगह infinity लगाएंगे, so 1 by infinity, it will become 0, so x will go to 0. Right, what will happen to the question? Question will become 1 plus 1 by n. 1 by n is x. And n is 1 by x. But here question is now in terms of x. So I will write limit x tends to 0 because x will go to 0 as n tends to infinity. So instead of n tends to infinity, I will write x tends to 0. Now here on the right hand side it is e. So this limit is also equal to e. So you remember this thing also, that this limit is equal to e. So limit x tends to 0, 1 plus x raised power 1 by x is equal to e. So आज के बाद आपको याद रखना है, if first term is 1, then you have x any term, then raised power the reciprocal of x, and x tends to 0, this limit is always equal to e. Now you remember this here, it is limit x tends to 0, 1 plus x raised power 1 by x is always equal to e. This e is actually a constant, Euler's constant. Its value is between 2 and 3. Write this. It's a special type of a constant. It is not a general constant. It is a special constant whose value lie between 2 and 3. Later on we'll discuss what is the actual value of e also. Now we have one more limit. Prove that the limit x tends to 0, a raised power x minus 1 whole divided by x. This is equal to log of a. Now I will prove this limit also. Limit x tends to 0, a raised power x minus 1 divided by x, where a is the constant. Where a is a constant. Where a is a constant. Now see how to evaluate this limit, how to find the value of this limit. See, you directly go x is 0 first. dj x को 0, a raised power 0, anything raised power 0 is 1. So 1 minus 1 will be 0. X is 0, so it is 0 by 0 form. So we cannot give the value direct x is equal to 0 because that is indeterminate. So we'll follow now the procedure. What is the procedure? You let a raised power x minus 1 be equal to say y. You call it y. Let a raised power x in the numerator, it is a raised power x minus 1. You put it is equal to y. That means a raised power x is equal to 1 plus y. Okay. Then a raised power x is equal to 1 plus y. Now have a look again. You change the limit as x tends to 0. जब आप x को 0 देंगे, दीजिए यहाँ x को 0, anything raised power 0 is 1, so 1 minus 1 will be 0, so y will go to 0. That means y will go to 0. That means as x will go to 0, y will also go to 0. Okay, number 1. Number 2, you take log here on both sides. Taking log on both sides, what you will get? If you take log on both sides, you will get log of a raised power x is log of 1 plus y. That is, x log of a is equal to log of 1 plus y. That means x is equal to log of 1 plus y whole divided by log of a. You remember this thing also. This is the value of x in terms of y. say I have taken log on both sides, so log of a raised to power x, it is log of a raised to power x, it is log of 1 plus y, because here it is 1 plus y. If I take log, it will become log of 1 plus y. It will become log m raised to power n, that is n log of m. It is log of 1 plus y. This will be x is equal to log of 1 plus y divided by this log of a. So you remember again, this x is equal to, so x is equal to log of 1 plus y whole divided by log of a. You remember this thing also here, right? And you remember that a raised to power x, it is minus 1, it is equal to y. जो हमने यहाँ लिखा, a raised to power x minus 1 is equal to y. Now, and you remember this limit, 1 plus x raised to power 1 by x is e, which we have put here. 1 plus x raised to power 1 by x is equal to e when x tends to infinity. Now, by substituting these things in this question, we'll see what will happen. Now this is limit x tends to 0, a raised to power x minus 1 divided by x, which we have to prove it is equal to log of a. So I have made substitutions. You know this, what I have done. Now I will substitute it here. I will write limit x tends to 0 will give us y also tends to 0. So I will write y tends to 0. Now a raised to power x minus 1, instead of a raised to power x minus y, I will write y. So it will be y divided by, in the denominator there is x, but the value of x I have obtained, it is log of 1 plus y divided by log of a. It is log of 1 plus y divided by log of a. Now this is limit y tends to 0. It is y divided by 1 into log of a divided by log of 1 plus y. I have put it like this. Say this is y divided by 1. This is divided by, so it will go in the numerator and it will come into the denominator. This is just simplification what I have done. Now after that, I will put it like this. This is further equal to log of a as it is divided by, this is 1 by y times log of 1 plus y. Now note this thing. This is here limit y tends to 0. See, this is y tends to 0. ये मैंने y divided by 1 को मैंने 1 upon 1 by y लिखा. जब आप इसको और ऊपर ले जाएंगे, it will again go here y. But here it is log of y divided by log of 1 plus y. Now remember this thing here. Take it very seriously. This is log of a. This is log of 1 plus y. So instead of 1 upon 1 by y, see 1 upon 1 by y. This is y simply. So this will come here again. Now after this, what I will do, I will write it like this. Limit y tends to 0, it is log of a whole divided by log of 1 plus y power 1 by y. See y. ये जो यहाँ है m log of n, it is log m raised power n, और log m raised power n, it is n log of m. So ये नीचे भी आ सकता है, ये इसके ऊपर वापस भी जा सकता है, because we have a formula in logarithm. Log m, if you have n here, it is log m raised power n. So you remember this thing also. Now after this, limit y tends to 0, it is log of a divided by. Now see, it is 1 plus y raised to power 1 by y. 1 plus x raised to power 1 by x. When x tends to 0, it is e. So it is same. 1 plus y raised to power 1 by y. When y tends to 0, it is e. So it will be log of e. This log as it is. But this limit is similar to this limit. Its value is e. So the value of this limit is also e. Now we remember one thing. Log of e is always equal to 1. So I will write here log of a divided by log of e is 1. So my result is log of a. तो वही तो मुझे प्रूव करना था कि वो जो लिमिट था मेरा, that is equal to log of a. So hence I will write here down. क्या मैंने प्रूव किया? मैंने लिखा limit x tends to 0, a raised power x minus 1 divided by x is equal to log of a. This you have to remember. So this limit is equal to log of a. You have to remember this. During differentiation also we have to use this type of a limit. We have to use this type of a limit. So you remember all these limits. So these are called the exponential limits.